This is our problem. We have an inverted U-tube manometer, and it contains three fluids. So you have on the left-hand side, you have carbon tetrachloride, and then this grayish portion is your oil. And then on the right-hand side, or the right reservoir, is actually your water. And it's specified in the problem that the oil has a relative density of zero point 0.8. That means to say that when we talk about relative density, I think you already know this one. That is just the density of oil divided by the density of water, because water is our reference fluid, and that is zero point 0.8, or that this is the RD, or the relative density of your oil. Also, it's noted that the reservoir on the left contains carbon tetrachloride, just what I have said, and it is pressurized to 9 psi. That means it has a gauge pressure of 9 psi. The reservoir on the right, however, contains water, and it's not pressurized in the same manner as the carbon tetrachloride because this is actually exposed to the atmosphere. So ang imuhang pressure nga influence on this surface is your atmosphere, or just the P naught. With the given data, you are asked to determine the height h, this h, uh, in the right reservoir, meaning the height h of the water. Because we know from our class that we have varying fluids with different densities, so mag-adjust na sila, maglihok-lihok na sila up until the point in which it reaches an equilibrium. So that equilibrium then is the thing that we need to find the H. Unsa ang H ato nga equilibrium state between your three fluids. So in our class, you are taught that the first thing that you need to know about this one is we need to set up the equation. Setting up the equation. So this is the very first thing that we need to do on this case. We need to set up the equation. And okay, I'm hoping you learned by now that you could actually do clever ways of doing this problem, no? So first thing that I would encourage you to do is to make explicit the water levels. Yun. Moon gini mo na siyang kuan kanang klaro ang kining mga water levels kay para magamit mo guni mo na siya later pa-analyze sa problem kana siya. Kini pod siya nga level diri kana. Now, if you are going to solve this problem, as I've said, you could start from either point. So you could start at this point A, or you could start at this point B. Whichever you prefer, you will get the same answer. So for this solution, I will start with A. So that means my equation will look like this, the pressure at A, and I'm going down to the fluid. Now take note, the first thing that I could do is I start from the top, go directly to the bottom. That means I will add pressure. And then from the bottom, I will go to this distance 1 feet, meaning I will decrease in pressure. And from that, up until the interface of your oil and water, I will go another 1 feet plus 0.7 feet. So I will be decreasing in pressure by this amount. Now that's a good way also of plugging in the values, but not practical. Because taas kayo mga equation anab, and you know nga you are moving in the same fluid, so nara ka sa carbon tetrachloride, so that means that the pressure that you actually gain as you go down, kini siya nga part bitaw, kini siya nga part na nag-gain mo nga pressure is actually cancelled out by the pressure that is decreased or nimo as you go up. So the net effect of the pressure is kini lang yun siya class, kini lang siya nga portion diri oh. I will put it in, I will shade it with this color. Kini lang yun siya nga height ang nag-influence nimo or nagdala og net effect sa imong pressure. So that's why I'm always saying that there are clever ways of approaching this problem, and the clever way is actually to do the jumps. Pwede ta maglukso-lukso ani sa atong pag-analyze because of what I have mentioned earlier na mag-cancel out lang pressure. So that means the practical way of doing is I will get the pressure from the top up until this height only. And I will call that height para for reference to be H1. That means that my equation will look like this. Since I'm going down, I will add pressure plus rho means the density of the fluid I'm moving, and that is carbon tetrachloride. And then you multiply it by G and H is just H1. Kini lang, kining very small height ni mo diri. Mao lang na akong gi-take into account. Now, on the same level, I have kani na ako diri na. Kaya nga naman, kato lagi kung mugikan ko diri sa taas padulong sa ubos, pagsaka na ko ana niya diri, so meaning kini na nga level, nag-decrease. Pagsaka pag siya diri, taman diri, nag-decrease gihapon, kini na pud nga level. So that means, I will take account of the pressure diri na nga level karon. So when I do that, I need to take note also that I'm now moving in the oil. So pagsaka na ko ani, taman ani class, yung top portion sa imong oil, mag-decrease kog pressure kay nagsaka man. Pero pag naog na po ako nagbalik on from the top to the same height, kay mag-increase ko og pressure by the same amount. That means nga mag-cancel out katong pressure na akong gi-minus, pag i-subtract, dayon na po gi-pressure nga gi-add by the same amount. So mag-cancel out na to siya diri nga kini nga portion sa akong liquid, sa akong oil. That means that the only pressure then that will exert or add a net pressure on my system will be katong gikan diri. I will erase that one for clarity. The only pressure then is katong gikan diri sa nga level padurong diri sa ako ang interface or boundary sa oil o water. So that means since I'm still going down, I'll have add na ko ang pressure, the density of the oil, and then G, and then the height. What is this height? That is 0.7 feet. So I have 0.7 feet. Okay, so I am now here. So I'm now in the interface of oil and water. Now, as I've said, nanabod kay technique diri kay if akong kwaon magud ang pressure gikan diri sa oil interface og water, padulong sa ubos mag-add ko og pressure. Right? Add ko og pressure butang P1. Pagkahuman, gitna na ko diri nga level no, level naman na sila diri. So kabaluta na when we are on the same fluid and the same level, the same pressure gina siya regardless of the shape. So if we move from this level padulong sa bottom, so kung P1 ni siya plus P2 na pata diri. Pero gikan sa bottom pasaka minus P2. Diba P2 man ni siya, so mag-cancel out lang ni sila diri kini nga terms sa mong pressure. And then gikan aning nga level padulong pasaka, di ba gikan aning interface sa imong oil ug water kay P1 man atong tawag ani. So na plus P1. So pagsaka na ko gikan sa kini nga level padulong sa taas, which corresponds to the interface of oil and water, is mag-subtract ko ni P1. So mag-cancel out na ba to siya diri. So that is why, since we are moving on the same fluid, the clever way of approaching the problem is to do the jumps. Pwede ta maglukso-lukso ani sa atong fluid. Pero bantayan gyapon ninyo kung sa mo pwede makalukso. That means from this, I will consider the pressure from the same level up until the top. So mao na akong i-consider, and that is pila man na siya. From this point up until this point, taas, that is our H prime. Take note na dili ni siya to scale class ha nga kanang abi kay kining diri nga portion bitaw nga 0.7 feet ni siya, nga 0.7 feet ra ni siya. So you will find it later in the problem. Nga dili na to na siya, kinahanglan na to magud siya i-express. Kini bitaw tong H prime, kinahanglan na to siya i-express into function of H, kay H man atong gipangita. So that means if I'm going to rewrite this part sa atong equation diri, kung kana siya, ay no, hindi siya maklaro. Change color. Okay. If the entire length is H, no, if the entire length is H, which is what we want, and then from this portion up until the top is your H prime. So karon, and then kabalo ka nga 2 feet ni tanan, di ba? 1 feet plus 1 feet, so meaning 2 feet ning diri sa ubos. So kinahanglan na to siya i-express ang kining H prime into H, kay H man itong ipangita. So this means to say that your H is actually the combination of 2 feet plus the H prime, katong small part nimo, kini nga part portion lang. So that means that your h prime then is given to be equal sa h minus 2 feet. So this is what you are going to plug in diri sa imong ubos, imong equation. So 0.7 feet. Okay, that is for the case of oil, and then we add plus, since we are moving up, the density of, we are now moving in water, and then G, and then H prime, as we see, is just H minus 2 feet. And then the last thing is you equate that with P naught, or the pressure at the surface, and then that is the atmospheric pressure. Since we are dealing with gauge pressure, the very thing that you need to note is katong mga P naught nimo, atmospheric pressure nimo, you equate it with 0. Because, take note, kana imong 9 psi gauge man na siya. Kumbaga, ang ato manggong gauge pressure, kabalutan na that is an excess pressure or measured with respect to the atmospheric pressure. So, marag na siya ba? Kung nabatay number line, tay 1, 2, 3, 4, diba? Measurement man na ito nga 1, may measure 1. Measure na ito na 2. So, kung mag-talk ta gauge pressures class, ang atong origin ana niya or atong reference point is the atmosphere, PATM. Manang may tag 1 nga gauge, 1 atmosphere as your gauge pressure, that means 1 atmosphere above the local atmospheric pressure of 1 atmosphere sub. So mao na nga 1 atmosphere nga gauge, 1 ATM nga gauge. So mao na nahitabo diri nga katong pinat nimo diri atmospheric pressure imo tong i-equate into 0 because we are talking of gauge pressures here, and gauge pressure ato ang reference nga point for measurement ana gyud is just the atmospheric pressure. Mao nang gi-0 na to siya. Okay? Kay take note, ang gauge pressure ba kay exists siya sa atmospheric pressure. Meaning kung mao ni akong measurement sa gauge lagi, kaning sa atong number line dito ano i-relate na to sa number line, ang akong origin ana niya class, meaning akong reference point gid ana is the atmospheric pressure. Mao na akong 0. So manang gi-0 na to na siya diri. So we are now left with a simplified equation kana 0 man na to ni diri no. So what we are going to do, I will change the color to blue. So ang atong buhaton ani is okay. Take note that the given, for example, carbon tetrachloride kay naka-SI ni sila tanan. So that means to say that we need to convert every single unit of height in SI. So we start with H1. So H1, that is just, pila man na siya? Kininos, kining sa taas. So if 3 feet from top to bottom, and then from the bottom up until this point is 1 feet plus 1 feet plus 0.7 feet. So that is 2.7. So 3 minus 2.7 feet. So that means H1 is just 0.3 feet. So 0.3 feet, you have to convert this into meters. So I think I don't have to show everything, but I will show it for the case of H1. Okay, the same process raman. So that means 0.3 feet. You multiply it by a conversion factor that in 1 feet you have 12 inches. Okay, 12 inches. And then in 1 inch, you have 2.54 centimeters. I think this is also given in the problem as a conversion factor. And then you multiply this one by 100 centimeters in 1 meters. 1 meter. So the feet will cancel out. The inches will cancel out. Centimeters will cancel out. So you just plug in these values to your calculator. Times 12, 2.54. Okay, divide by 100. You have 0.09. The height is 0.0914. And this is now in meters. So this is an SI unit of length, meters already. So wala kay problema ani. This is your height. And then the next thing is you have 0.7 feet. So I will not go into details how we get 0.7 feet. Basically, it's just the same thing as you did above. So I will work with that on my calculator. Okay, 0.7 feet divided by 100. So you get 0.2134 meters. So that is 0.2134 meters. And we have for 2 feet, we convert that into SI. You will have, okay, let me just change my input on calculator. 2 feet divided by 100. Okay, so you have 0.6096, 0.6096 meters. But we don't have a problem with our units now since these are in SI already. So we are going to manipulate this equation. I think I'll go with blue. Our goal is to isolate this term here, the thing that contains your height h on either side of the equation as long as isolated siya, because we need to find for this h man. Okay, so before that, the thing that we need to consider is it's really made clear in the problem na ang oil limonage ay relative density of 0.8. So from this, we could actually have the density of oil to be equal to 0.8 of the density of water. So I just did algebraic manipulation on the equation of relative density and you arrive at this one. So this is important because the density of oil is asked in the equation. So you are going to substitute this value into this equation here. So when you do that, you will have Pa plus the density of carbon tetrachloride multiplied by the acceleration of gravity. And then H1, I will plug in na lang, no? H1 is 0.0914 meters, 0.0914 meters. And then plus the density of oil, as we have re-expressed here, is 0.8 of the density of water. So you have 0.8 multiplied by the density of water. And then you have 0.7 feet, and that is 0.2134 meters, 0.2134 meters. Okay, and then I think I lack some space, so I have to erase these terms here. Okay, and then you add the density of water GH. Okay, so you need to take note that, okay, so we actually made a mistake on this part here. Take note that you actually moved from this level going up, so that means it should bear a negative sign because the pressure decreases as you go up. So isa ni siya ka thing na dapat nato constantly conscious dahil, no? Kaya ni nasayop na kong sulat. So it should be negative ang yang sign. Kaya mag-decrease man yung pressure as you go up. And you actually take the pressure going up man. Gikan ani nga level pasaka. So what happens is you need to distribute this term to each of h and 2 feet. So mahitabuan na kay when you do the distribution, no, na kay negative of the density of water multiplied by g and then height h. So kini mo na itong question, pangita ang height h. And then when you distribute the negative to negative, so you have positive 2 feet multiplied by the density of water times g, and that is equal to 0. So another thing that you probably remember in class is you have the term for another characteristic of a fluid is this term, the specific weight represented by gamma, and that is just the density of the fluid multiplied by the acceleration due to gravity. And you actually saw this to be an important thing to recall because you notice in your problem that density, sorry, I need to change color. You notice in your problem that the density is actually multiplied by the acceleration due to gravity repeatedly. For example, this case, you also have, oh, we forgot G. Nalimtan si G diri class. Napa ni si G diri? In this case, you have 0.8 times density of water, that is the density of oil from this one. No? So we actually forget G. So napa ni G diri? Times G. Okay, so if you can see, you have density of oil times G gihapon. Kini gihapon, gihapon rho times G, rho times G. So that means we could actually simplify our expression by utilizing the fact that the density times the acceleration due to gravity is just the specific weight or gamma of the fluid. So that means that we could actually do this to simplify the problem. And since specific weight is also given in the table above, so mas dali na to na siya masulbad. So we have PA. I should be changing to blue, back to blue. So I should have PA. And then this term here, rho times G, and that is the density of carbon tetrachloride. So that will be the specific weight of carbon tetrachloride multiplied by 0.0914 meters. And then after that is you add 0.8, and then the term density of water times G is also the specific weight of water. Specific weight of water, so na-simplify na siya. Multiplied by 0.2134 meters. 34 meters. And then, okay, so this term that you see here bears the negative sign, and this also bears the variable with which we want, kining h, mao man itong desired value na makuha. So I am going to transpose that to the opposite side. Kaya mas dali man para mag-positive na siya pag abot dito. So what is left is this term na lang. So plus 2 feet multiplied by, if you try to look into this one, it is still density of water times G. So that is the specific weight of water. Okay. And what is left on the opposite side of the equation, from negative, positive na siya since it's transposed to the opposite side. And you will have the density of, okay, the same thing. The density times G is just specific weight of water. And then you multiply the specific weight of water with your desired variable, your height h. So from this one, you can actually divide both sides by the specific weight of water so that you can only have, or you arrive with h on the right hand side, which is what you desire. Okay, mao man natong ipangita. Okay, so the specific weight would cancel out in that case. And so I have now an expression for h, and that is given by this expression, PA plus CCl4 multiplied by 0.0914 meters plus 0.8 density of specific weight of water. But you could actually still do this problem nga katong density lang gyapon yung gamiton. Density of acceleration due to gravity, you can still arrive with the same value. But this is more kuan magod, mas kuan siya ba? Oh, okay. We should have converted also 2 feet. In this case, kining 2 feet din nato para consistent as a unit is, that is 0.6096 meters. So this is just 0.6096 meters. So we are going to use this para consistent nga SI tanan. Dili ta maglibog later ba sa atong unit sa atong value nga nakuha ni H. So you multiply that by 0.6096 meters, or just the SI of 2 feet meters, and then the specific weight of water. Okay, you divide this everything by the specific weight of water. Now it's pretty clear and straightforward from these lines of equation that you are simply going to plug in the values. So I will not put it here, the values, but I will put what I will put instead here is, oh, I think I have to. Ako na lang ibutang para mas makita ninyo ang conversion dahil sa units, no? So PA, you know that PA also is given in the problem to be 9 psi. So let's convert that. PSI is not an SI. So ito na i-convert into SI unit. So we have 9 PSI. Convert that into pascals. So 1 PSI is 6894.76. So 6894.76 pascals in 1 PSI, or 1 pound per square inch. So that means you will get the value of, we work on that, 9 times 6894.76. 6894 million. You will have 62,052.84 pascals. So you have now pascals as a unit, which is the SI unit for pressure. So consistent na ta, SI tatanan. So when I plug in these values, ako na lang silang ipambutang para kita ninyo ang iyaha bitang cancellation of the units, because working with units is very important. It tells us whether we are working with the correct nga equations pa. For example, so PA is 62,035 PA. So PA is just Newton per square meters plus the specific weight of carbon tetrachloride from this table is 15.6, and take note that is kilonewtons, meaning 15.6 times 10 to the 3 newtons per cubic meter. So we will have it here 15.6 times 10 to the 3 newtons per cubic meters, and then you multiply it by 0.0914 meters, and then you add 0.8, and we are going to our reference for the specific weight of water, and that is 9.80, still kilonewtons per cubic meter. So that's 10 to the power of 3, 9.80 times 10 to the power of 3 newtons per cubic meters. Okay, so and you multiply it by 0.2134 meters. 34 meters. I think I have to since we have already used this 62,000, I'm just going to erase this one because I lack space. So we need to continue with the last term of the equation, kinisha. So you multiply 0.6096 meters with the specific weight of water. We have already referred to that. That is 9.80 times 10 to the 3. 10 to the 3 newtons per cubic meters, m cube. Okay, now we are going to investigate. I know I have not written yet the denominator, but let's try to investigate what happens in the numerator. So in each of these terms, the meters will cancel out. One of the meters will cancel out, so you are left with newtons per square meters, which is basically pascals. The same thing happened here. 1 meter will cancel out. 1 meter will cancel out. So each of these terms that you have here are in units of pascals. So meaning naa sila sa unit na Newton per square meters. Because that is 1 pascals. 1 Newton per square meter. Okay, so let's continue with our denominator. For our denominator, that is just the specific weight of water, and we know that to be 9.80 times 10 to the power of 3 newtons per cubic meters. So right now, you notice that the equation actually yields the numerator to be, so let's just skip first the numerical value, but let's try to look into the units. So for the numerator, you have Newton per square meter, or just Pascal. And then for the denominator, you have newtons per cubic meters. So when you manipulate this denominator and numerator, so since division of fractions man na siya, so that means that I could solve that by multiplying the denominator, this term, the reciprocal of this denominator, ako na siyang i-multiply sa numerator. So the reciprocal of that is m cubed per newton. So what happens is newton will cancel out, meter square will cancel out, leaving 1 meter. And so you have arrived with a unit of meter, which is what you desire for a unit of height. Kay meter man gyud siya an NSI. So we don't have a problem with our units. So that means we are actually using the correct equations, the correct set of equations in our problem. And what is left then is to carefully plug in these values into our calculator. And when we do that, for the numerator, we have 60,035 pascals. So 62,035 pascals. Okay. You add 15.6 times 10 to the 3, multiply it by 0.0914 meters, plus 0.8 times 9.80 times 10 to the 3, multiplied it by 0.2134 meters, plus 0.6096, multiplied it by 9.80 times 10 to the 3. So the numerator will yield you a value of 71,107.976. I'll just max it out, 976. Of course, Newton per square meter. And then the denominator is as is 9.80 times 10 to the 3. That is Newton per cubic meters. So when you plug in these values in your calculator, you should get, you divide that by 9.80 times 10 to the 3, you get the height to be 7.26. So it's actually 7.2559, but 7.26 meters. So that means that the height of your water reservoir here is 7.26 meters from the bottom, meaning from this portion to the top portion, that is accounting for a height of 7.26 meters. Okay, so that is how you solve this problem. And the salient thing that you need to remember is that since we are dealing with gauge pressures, automatically the atmospheric pressure that we arrive with, meaning kining pressure na to diri nga surface ba, kay ato to siyang gi-equal to 0 since we are dealing with gauge pressures. And in gauge pressures, our base unit or our base nga kana bitang origin kumbaga sa atong number line, if we associate with number line, is the atmosphere. So mao na nga 0 gito siya atong mga PATM or atmospheric pressure.